so just as review, properties of parallelograms. A parallelogram is a quadrilateral. Both pairs of opposite sides are parallel, so that's actually one of your characteristics. Other characteristics, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. All right, so for number 1, they've given you one angle and one side, or two sides rather, and they wanted the rest of the information. So AD was congruent to BC at 8, DC was congruent to AB at 15. The measure of angle A was supplementary, so you should have subtracted from 180, that's 112. B was congruent, 68, and C was congruent to A, which was 112. All right, for this one, UT was congruent, so 27. ST was congruent, so 18. VS was congruent because it bisected, so you should have gotten 7 there. And they have that RT was 30, so you could have cut that in half to get the VT of 15. Questions on that one? All right, the last one. They've given you some information. I would suggest you write it where it goes so that you can see it, just like the visual help above when you have it. But these are your answers. ZW was 15 because they gave you XY. ZY was 22 because they gave you WX. TX was 16 because they gave you all the way to ZX. You should have just cut it in half. WY was 20 because they gave you half, and you could have doubled it to get that one. Okay, so TZY. They gave us 3 different angles. They gave you WZY of 62. They gave you WXT of 27. And they gave you ZWT of 77. So for this TX, or TZY rather, which is right here, because they gave you WXT, these are alternate interior angles. Remember, these are parallel lines, and that's the transversal. WYZ right here, WYZ. And they gave us, so using what you have here with the 62 consecutive, this entire angle, which is the XYZ, is 118 by subtraction. And then they also want XW, let's see, XWT, which is this guy right here. I'll use a different color. All right, so they want XWT, which is here. All right, if I know the whole thing is 118, and I know part of it is 77, I can just subtract 77 from 118 to get 41. Because if this is 118, that means this is also 118. And I know part of it. I know part of it is 77. So consecutive angles, right? Adjacent angles just add up. So 118 minus the 77 would give you the 41. And then we know by the same thing, alternate interior angles for this last guy. That should also be 77 as well. All right, which is what they were asking for here. X, Y, T. Properties of rectangles. We have talked about them. Your handout lists all of the properties of the parallelograms because those do apply to the rectangles. But you also have the additional ones. The 4 angles are right angles, and the diagonals in a rectangle are congruent. So not only do you have all the characteristics of your parallelogram listed there, you also know that all 4 angles are right angles and that diagonals are congruent. So not only do they bisect each other, they're also congruent. And so we're going to do a couple of problems only related to rectangles, that deal with those properties right there. So the first one we're going to do is number 1. They've given us some information. And so we're going to use what they've given us to solve the rest of it. The first one they ask for is QR. QR. So we're going to find it on our diagram. They gave us the opposite side, which was PS 10. And so we know, without doing any calculations, that QR is also 10. SR. Once again, We have SR, and it is directly opposite of PQ, which they gave us. So without any calculations, we know that that one is 24. Now they want SQ. All right, so SQ is a little bit different. Just looking at this, we don't have anything so far that they've given us to get us SQ without doing some type of calculation. SQ is right here. Now, what we do know is that we have 4 right angles. So I do know that this is a right angle, which means I do know that this is a right triangle. And I have 2 sides of a right triangle. So what theorem can I use to find the third side of a right triangle? Yeah, Pythagorean Theorem, which is what? A squared plus b squared equals c squared, which we have used multiple times this year, right? And so I can solve for that side by simply doing my 10 squared plus my 24 squared equals my c squared. All right. When you add these up, you're going to get 676. And when you take the square root, you're going to get 26 there. So that's how they got the 26 for the SQ. They used the Pythagorean theorem. Now the next one that they asked for is PR. PR is the other diagonal. Well, what did we just say about rectangles? We just said that diagonals are congruent. So if I solve for SQ, which was one of the diagonals, and they asked for PR, which was the other diagonal, we just said they're congruent. So I know this one is also 26. All right. The last thing it asked for is Q to T. QT right here. That's half of one of the diagonals. Based on just the parallelogram information, we know diagonals bisect each other. So if I know the diagonal is 26 and I know they bisect each other, then I can just cut this in half and say that is 13. So let's look at number 3. Number 3 has given me some angle information, and they want the rest of the angle information. All right, and so this is going to be dealing a lot with parallel lines, right? Because we know some things about parallel lines as well, and right angles. So the first one they ask for, you always want to make sure you know what it's talking about, M, J, K. So just follow it along, M to J to K, all right? They want this whole angle measure. Well, one of the attributes of a rectangle is that all of them are right angles, and they ask for one of the angles. So I don't have to do any calculation. A right angle is 90 degrees. So I know that MJK is 90 degrees. All right. The next one they ask for is MJL. So they want MJL. All right. Well, if I know the entire thing is 90 degrees, and I know part of it is 27, the other part I just calculate by subtraction. So I'm just going to say, well, I know the whole thing is 90. I need to subtract the 27 to get that particular angle. And so that's how I'm going to find that this is 63 degrees. All right. All right, the next one it asked for. So after this one, it's going to ask me for JLK. So they want JLK. All right, so if I look at JLK, now I have to use my knowledge of parallel lines. All right, if these are parallel lines, that means that J to L is a transversal. And that means the angle that I have up here and the angle that I'm looking for are alternate interior angles. Okay, alternate interior angles. It also means then if I do the same thing over here. So I just solved for this one. If I have parallel lines here and parallel lines here, and I think I drew it backwards, JL to K, JLK. Then that means this one that I just solved for and that one that it's asking for. So I can find a couple of these just by using alternate interior angles, all right? And so if it wants this one, JLK, it's going to be exactly what I just solved for. It's going to be the 63 again, because I have two sets of parallel lines with two transversals that creates multiple alternate interior angles. All right, and so you kind of start working around the piece of this a little bit. For the next two, if you look at these, they want KML. I'm going to actually erase some of that so we can see it a little easier. All right, so they want KML, which is this one. All right. And then they want MNL, which is what's left over up there. So when I start looking at these, I'm going to work my way around this particular problem. So I have 27 here, so I know this one is 27. We said this is 63, so I know that this one is 63, all right? And then I start looking at what's happening with these parallel lines. And so if I use this parallel line and this parallel line, I have alternate. And then if I use these two, I have alternate as well. And so I start looking at what's going on. This must also be 90, and this must also be 90. And so you actually start seeing it grouping with a rectangle. If this is 63, this is also 63. The reason I know that is because my diagonals bisect each other and they're the same. So I actually create this isosceles triangle. So my base angles are the same, right? And I create this isosceles triangle, which means these base angles are the same. So rectangles also create isosceles triangles. So once you have figured out the angles within one of the diagonals, you have figured them all out, because you have, based on the proof of alternate interior angles, you know all of them, and you also know you've created isosceles triangles. And so if they want K to M to L, well, it's just going to be 27 because of this isosceles triangle here. And if they want M to N to L, well, I can just take this isosceles triangle out that's over here, and I know the two base angles. So how do I calculate the third? Well, I can use my information of 180, right? To find this one. If I want this one, which is the one they're looking for, I have two base angles of 27. And so I can use what I know about three angles in a triangle. And so I can say 180 minus the two base angles to get that. And so they're going to get this 126 from using that information, 27, 27, and the third angle, which is what they're looking for, is my information on that. So when they ask for this guy right here, which is MNL, they're asking for this one. I've already calculated the 27 and the 27, and I can just subtract from 180, because rectangles create isosceles triangles. You've just told me the side lengths are the same. If the side lengths are the same, two side lengths give me an isosceles triangle. All right, so you have to pull back on information, parallel lines, isosceles triangle. You have to pull back from information that you may have from prior chapters to do this. For this first one, they wanted from A to C. They gave you half of it. You just double it. The two diagonals are congruent, so that's 30. If this is also 30, half of it is 15. If they gave you DC, you know AB is congruent. And then for BC, you actually can use Pythagorean Theorem, but you have the hypotenuse, so you have the 30 here. That's your hypotenuse. 27 was one of your sides. You're solving for the other. So you had your C on this one, so you have A squared plus B squared equals C squared. So that is why you would have set it up that way. Any questions on that one? All I gave you was one angle measure. The first thing they ask for is X, W, Y, which is this base angle of the isosceles. So you could take the 180 minus the 64, which is going to give you the 116, but that's both of them. You have to cut that in half because the base angles are congruent. So that would give you the 58. The next one they ask for is y, x, and z, yx and z. If you know this one is 58, because you know they both are, this whole thing is 90, so you should have taken 90 minus the 58 to get the 32. W, V to Z. These are supplementary, so you could have just said 180 minus 64 there. They are supplementary. When they just ask for one of the angles, it's going to be 90 degrees, right? So they just ask for XWZ, which was just one of your right angles in your rectangle. And then the last one, you could have used alternate interior, or like we already established, once you have a rectangle, you have basically two sets of congruent triangles. So, you know, these two are congruent triangles and these two are congruent triangles. So you can just assume the base angles are congruent for both sides of those because you have congruent triangles. So if you look at these, you can see that your side lengths are going to be solved really the same way. Either some things are congruent or we have maybe a right triangle to deal with. And for angle measures, it cuts it in half. So I have congruent here, these are congruent. I have congruent here, these are also congruent, and I can use my supplementary to get that. And this guy, these are always going to be 90 degrees for a rhombus. Always, the center ones are. So make sure you label what you have. You have EF of 23. That really tells you every other side. Every other side. So when they ask you for GF, that is also going to be 23. They gave you a diagonal. So they gave me the entire thing crossed was 40. They asked for HF, so that should be half of it, which is 20. And so then when they ask me for something like G to H, I can use the Pythagorean Theorem here. I have the hypotenuse of 23, one of the sides of 20, and I can get that that is 11.4, and then G to E should be the double of that, 22.8. All right. You'll notice that for this, it doesn't have anything for you to write down because it's all prior characteristics. All right. It is all the characteristics of the parallelogram, all the characteristics of the rectangle, and all the characteristics of the rhombus. So they are all listed here. So then when we start solving this, you actually start seeing 90-degree angles everywhere, not just on the corners, but also at the diagonals. You see bisected angles, so we know angles measurements pretty quickly for these. And so it actually becomes a little bit easier to even solve this. If ABCD is a square and AD is 11, find each missing value. So, of course, I'm going to label what they gave me first. BC, that's one of the sides. I know it's that. All right. Well, if they want A to C, I have a right triangle here. So I have this right triangle right here. They want the hypotenuse. I'm going to use Pythagorean Theorem here to do this. So I'm going to say 11 squared plus 11 squared equals my C squared. 11 squared is 121, so I get 242 when I add those together. That doesn't have a perfect root, so I'm going to get 15.6 as my diagonal there. B to D, I know from all my prior attributes, my diagonals are the same. That's the other diagonal. E to C, that's half of one of my diagonals. So I take the 15.6 and I cut it in half. That's 7.8. So really, once I've found, one side's all I need to find every single side, every single length measurement in this entire thing because it's a square. Then they start asking about angles. They want DA to B. That's one of my angles in a square. Well, one of my angles in a square is always 90 degrees. They want AE to B. That's actually makes up from A to E to B is made up from my diagonals. Well, just like a rhombus, my diagonals are perpendicular. So the intersection of my diagonals will also be 90 degrees. C to B to D. All right, so if I go back and see this one, I have C to B to D. Well, all my angles are 90 degrees. My diagonals cut them in half. So the only options here for angles in a square are either 90 degrees or 45 degrees. Is it a whole angle or is it an angle that's been cut in half? So this is one that's been cut in half. So this one is 45. B to A to C is the same thing. It's one of my corner angles that has been cut in half. So that is also 45 degrees. All right. This page also throws in another rhombus. So we're going to do one more with a rhombus here in sides. It can do the same thing that we've done all along. It can throw variables in there, not just numbers. So just like from your homework where we had parallelograms, if you have something like this, you're going to just set it equal to each other. So you may have to use the property to solve for the variable as well. And just make sure that if they're asking this, that you know if you're solving for the variable or if you're solving for the side length. In this case, it said M to P. M to P. This is a rhombus. All the side lengths are the same. So I can plug it into really either one of these. Doesn't matter which one. And I can solve for it because they will all be the same length, 49.